Hello, and welcome to Engineering with Rosie Live, up to episode 11, which is very exciting to me. That sounds like a lot. In this live stream, we're going to be talking about the different technology options we have to decarbonize trucks or lorries. If you're watching from Britain, which is where today's expert guest, David Cebon, is. Hi, David.
Hey, Rosie.
So I'm going to introduce David properly in a second, but in the meantime, I'm keen to hear from you, from everybody watching, listening. Where are you watching from, and what heavy transport solution or solutions do you think suit your location best? So yeah, get in the comments and tell me what you think there. Yeah, so we're going to be covering all kinds of clean trucking technology options, drop-in fuels, battery electric, hydrogen, and electric road systems, and answering all your questions. But before we get to that, I want to thank the sponsor of these live streams, which is WeatherGuard Lightning Tech. WeatherGuard makes strike tape, a retrofittable lightning protection system for things that go fast, so like wind turbines or aeroplane wings. And these live streams wouldn't happen without their support, so I'm very grateful for that. And of course, the whole Engineering with Rosie channel is supported by the amazing Patreon community. We're up to 111 in the team now, and we would love to welcome the 112th. And I have some really good questions submitted ahead of time from the Patreon team to get to throughout today's show. So now to introduce our guest today, it's Professor David Cebon. David is like me an Aussie, but he's now based in England, in Cambridge, right? Where he's a professor in mechanical engineering. So David, welcome. And can you just tell us quickly a bit about your career and what your research interests are and what caused you to get interested in the energy transition in general and related to heavy transport specifically?
Oh, thanks, Rosie. Great to be on your show today. Thank you very much for inviting me. I'm a mechanical engineer. I studied engineering in the University of Melbourne and went to the UK to do a PhD, and I kind of got stuck there, and I'm still there. My PhD was in heavy vehicles, believe it or not, and it was in the area of road damage caused by heavy vehicles. I worked on that for about 15 years, pretty flat out, actually. And I've worked on heavy vehicles throughout my entire career, and I won't tell you how long that is because it's longer than I care to admit. But the last 15 years or so have been on fuel consumption, vehicle emissions, and climate change and all those issues.
Okay, that's interesting. I didn't even know until right now that you started out with trucks, because I obviously got to know you through other energy transition stuff, and yeah, we've talked a lot about hydrogen through the last year or two.
Yeah, well, there was a lot of work in between. I still work a lot on safety of heavy vehicles and productivity in those areas. And productivity particularly is important, because if you can have a single truck that carries more stuff, it uses a lot less fuel, a lot less fuel per ton kilometer of freight transported. And that's really one of the low-hanging fruit items of low-hanging fruit is improved productivity, and that actually is at all scales. If you replace 20 trips to the supermarket with one home delivery vehicle, which is doing multi-drop, that's a higher capacity vehicle, and it is much more productive and uses a hell of a lot less fuel. So, and that same thing applies at all scales. Through, if you can replace a 7.5 ton truck with a 14 ton truck that's full, you use a lot less fuel. And
so I don't need to feel guilty about I've recently gotten quite lazy, and I almost never go to the supermarket anymore. I get it delivered.
The supermarket is pretty good. I think that there's issues when you buy 5 pairs of shoes and send 4 of them back. And
I also do that.
Yeah. Home delivery is not the panacea, but it can, when used well, it can really reduce our fuel consumption. But the extreme end of this is those huge road trains that you see traveling across Australia. 50 meter long, 55 meter long, 120 ton road trains. They're incredibly productive. They use.
Are they only in Australia, or is that a worldwide thing, the road train? Because I might show a picture of it.
Australia's the winner. Australia's the winner by far on those. They are used in other countries, but not at the extremes. Australia's very, very, very progressive on these very high capacity vehicles. Yeah, brilliant. Great.
I just pulled out some pictures because people might not be aware of what a road train looks like. It's insane, actually. We should find some because they actually do go on roads as well. It's not just not just dirt roads.
That's right.
Okay, well, let's keep cracking on. I want to keep a good pace today, and try and stick to the hour. So it started off with a poll on YouTube, a community post, a poll. And I phrased it a little bit interestingly. I said, what's the best way to decarbonize heavy transport? And then I said, in today's live stream, we'll talk about green trucking options. So in the poll, hydrogen came out the winner, followed by battery electric, then electric roads. No one likes biodiesel. A lot of people really just love to see poll results, so I always include that option. But the interesting information was what I didn't put in the poll, and everybody said trains, trains, everything like that. And someone, pointed out my obviously Australian perspective where, we don't use trains a lot in Australia. I loved that when I was living in Europe, catching trains around. So I think that the first thing that we need to talk about is where do trains fit in? It's not what we're mostly, I'm going to just be clear, we're mostly going to be talking about trucks in today's live stream. And I do want to do a video. I have actually some interesting renewable train projects that I want to make a whole video on later. But yeah, David, can you tell me what's your opinion on this and how do trains fit into the equation?
Yeah, well, trains work really well for long distances between cities. And there are a number of examples of long train lines in Australia, in Europe, even in the US. The US is less good for trains nowadays. If you go to India, long train lines, and often with roads traveling in parallel with them. So there's no point. Ideally, those are opportunities where you've got long train journeys between cities. They're great opportunities for moving freight by train, no doubt about that. In the UK, we've got rather short journeys. No one drives more than 300 miles from A to B. No truck goes more than a few hundred miles, and it's very hard to make that work with a rail system because you have to, put stuff on the train at one end and put the stuff off the train at the other end. It's got to. There's no supermarket has a railway siding, so you've got to get your freight from the railways to the end user, the end customer, and unless you have a long enough length of haul, you just really can't justify the triple handling. That handling before you put it on the train and after you put it on the train, the first mile, the last mile, and so trains definitely have a place in the system, but they don't replace trucks. You can't replace trucks. You can't get deliveries to the end user with trains in any way, and they work really well for long distances. So we should certainly integrate rail as much as we can. The other aspect of it is that it is a pretty small amount, and in the UK, it's less than 10% of all land freight transport by train. And even if you doubled it, which is a huge stretch because it's already at capacity. Even if you doubled it, you still would only be having a small impact. So there's just no way that rail is the solution.
Okay, so we'll move on. But first, I want to show a couple of comments that I liked. First, from Pinata Oblongata, I choose trains, and this is I'm from that era where I grew up with the Simpsons, and I remember that Simpsons episode, so I appreciate that one. Thank you. And then secondly, from Supers 05 or Super S05, I never know how to say that. apparently Australia has a record for the longest and heaviest trains, assuming that you mean probably for transporting coal and iron ore and stuff. And yeah, I will definitely be in touch when I want to make this video on trains. One of the projects I want to feature is the Infinity train. I don't know if you've heard about it, David. It's a Fortescue metals thing. And the idea is you take iron ore, which is, like uphill, and and then you transport downhill, you use that's like a gravity energy storage, because the train is lighter when it goes back up the hill. You can get this like perpetual motion kind of thing from that project. So
Yeah,
I think
well,
that is pretty cool.
That's an interesting one. I used to work in the Pilbara once upon a time. Hammers the Iron used to have 5 locomotives pulling full trains down the hill from Tom Price and Paraburdoo down to the coast, and they would have 5 trains pulling the empty cars back up the hill. Even going downhill, the rolling resistance is so enormous on a 1.5 mile long iron ore train that you still have to pull it. So I'd be interested to see how Andrew Forrest pulls that one off. It'll be another
he has a lot of ideas, and they don't all come to fruition. So I'll get in touch with you when I'm writing that script to make sure that I don't make any clangers in that one.
Yeah.
Okay, so let's move on to describing the problem. So we've got okay, let's assume that we move as much as we can to trains, but that still leaves a big issue. Oh, and actually I have a graph that I can show. So this is from an NREL report, the US National Renewable Energy Laboratory. And anytime you want to do a green energy topic, then they've always got this lengthy report that you can use. This one's 69 pages long. And so they've looked at all of US greenhouse gas emissions. 33% of it comes from transport, and of that, 21% is medium and heavy vehicles and 30% light trucks. So I guess that's the portion that we're talking about today. Obviously, there's also pollution, and I don't know what else. Well, how do you see the problem, David?
How do I see the problem of decarbonising trucks? Well, it's been driven very much by the pollution issue over the last 10 or 15 years. That's really been the driving force, and it's a driving force towards electric urban delivery vehicles, because the air quality emissions are particularly an urban problem, and it's driving adoption of battery electric urban delivery vehicles. And I really think that in 10 years' time, we'll look back and we'll say, why do we ever drive diesel trucks in cities?
Sorry, I lost you for a second. It might have just been me. I'm on
okay.
NBN, Australian National Broadband Network, isn't known for its quality.
The Cebon broadband network's not brilliant either, so we'll see. You might have. Yeah. So urban delivery vehicles. The trucks. You can do a delivery from an out of town depot. You can drive 100 or 150 kilometers with an urban delivery vehicle. It's clean and quiet and low cost to operate. You go back. You go back and charge up when you get back to the depot. It's pretty straightforward to do rubbish trucks, to do urban buses. All these things can be electric, and that's the way it's going. And I think we'll see that accelerating over the next little while. So the difficulty comes with the long haul freight and the long haul trucking, which is what everybody immediately thinks of. But it's of course it's in the UK. It's about 2/3 of the issue. So the first third is going to fall quickly, and that'll be battery electric. That's good because that's setting up vehicle supply chains and OEMs making technology for battery electric trucks, and gradually we will see more battery electric vehicles. The problem with long haul is not the vehicle technology, it is the charging technology. How do you charge the trucks? That's really the issue. We can make vehicles, battery electric vehicles that can pull big enough loads. The question is, how do you charge them and how do you keep them charged? And that, believe it or not, is entirely dependent on the job that they're doing. And trucks do different kinds of jobs. Not all trucks drive up and down the highway all day long. Trucks do multi-drop deliveries around around rural areas, doing drops to supermarkets, or regional. They drive from distribution center to distribution center up and down the motorway. So there's all kinds of different journeys, and you have to take those journeys into account if you're going to design a system. It's not good enough to say, well, 50% of vehicles do journeys less than X kilometers, and therefore we can just use batteries, because we can't. That doesn't work.
Okay, well, let's dive into some of those specific technologies and the use cases that they suit or don't suit now. So wanted to put them into 4 categories. First, what I call drop-in fuels. So you take a normal truck and just replace its diesel with e-fuels or biodiesel, and then we'll get to battery electric, hydrogen, and electric road systems. But can we just start with drop-in fuels? What have you noticed? Have you noticed this is a trend? Is this increasing? I don't feel like I hear so much about this anymore.
Well, there's been two big shifts in the last 5 or so years. One is a shift to gas vehicles, certainly in Europe, so gas-powered vehicles, and there've been various iterations of that. And some of them are dual fuel, where you use diesel to ignite methane, and they are less popular. But Volvo has some quite good technology there. They've had those technologies have had problems with incomplete combustion and methane leakage, methane slip. So that's one issue. One area is methane, and now spark ignition technology is so Otto cycle rather than diesel cycle is the way that those are going. And there's quite a lot of those around. They can burn natural gas, they can burn biogas, and if they burn biogas, they're pretty clean. 70 or so % reduction in carbon emissions from those vehicles whole life.
But you still get the localized pollution, right? Is that exactly the same?
A bit less with gas than diesel. So you don't have the same problem with particulates. And you have less of a NOx problem. So and with Euro 7 vehicles, the standards are pretty good now for air quality. So air quality from gas trucks is good, and they are not a bad interim position for fleets that are trying to decarbonize, and quite a lot of fleets are doing that. The other direction is HVO, hydrogenated vegetable oil, as well. And what they're trying to do is meet their short-term targets. The problem with biofuels is that there's never going to be enough of it it's never going to be a solution for everybody. And we have to be thinking about solutions for everybody. So biofuels will never do that, because there's never going to be enough. But as an interim measure for those fleets that can do it, all power to the elbow. They're making a difference now.
Okay. Let's move on then to battery electric, and we have to start by talking about the Tesla Semi, because I don't know, somehow, Tesla does. It comes up. People always want to talk about Tesla and Elon Musk. So it was one of the Patreon questions that I had is what's going on with the with the Tesla Semi, and so that's the reason why I have this article here. What's the current status of Tesla's electric hauler? I actually read an article that said we're not getting them in Australia because they're too wide for our roads. Do we have narrow roads in Australia? That's interesting.
Well, I don't think the width is a problem. I think there's this. I mean, I don't have any special insight at what's going on in Tesla, but I have written about this vehicle. I wrote about it some time ago. It's very challenging to make a big battery electric truck with enough capacity to really do the job. And this is one. I mean, it's doubly difficult in the US. The US, the size of that truck, the weight of that truck is 80,000 pounds. That's 36 tons. We carry 44 tons in the UK, and Australia similarly. So this is a very lightweight vehicle. In order to get the range that it needs to get, it's going to carry an 8-ton battery. And so 8 tons, it's taking at least 6 tons out of its 15-ton payload. I mean, it's a calculation which is not good. It's very hard to
Okay. So
see.
what are they aiming for? Like what use cases are they aiming for here? Do you know?
Well, they've done what a lot of people have done, and then said, well, okay, US trucks, the average journey, US truck journey is only 200 miles or 300 miles or something like that, and so therefore we'll fill that market. But that completely fails to understand how logistics works. The truck that does 200 miles, it does 200 miles and it turns around and does another 200 miles. So its battery's got to go for 400, 600, or 800 miles. It's not good enough to make a battery electric vehicle which just does 200 miles. Now you can charge it reasonably quickly, but in order to understand, to get these kind of vehicles to work, it's the charging. As I said before, it's the charging which is the whole thing. You have to have a strategy for charging. If you don't have a proper strategy for charging, these vehicles will never work. They're too heavy and they're too expensive to run on big batteries all day long.
Okay, so what are the use cases then that are really well suited to battery electric? And I mean, obviously, I've already seen plenty of projects announced. I think IKEA and Amazon are starting to do deliveries with battery electric. I've also seen some swap and go systems for battery electric trucks to swap their battery out quickly. What do you see as the interesting opportunities for battery electric trucks?
The use cases that we're seeing, where people are actually saying we're using these 44-ton big battery trucks, they're short distances, and they're short distances that can be charged in depots, and these trucks will do that. Will absolutely do that kind of job as long as you charge them during the day. Battery swapping is an interesting idea. The Chinese are getting into battery swapping a bit. It's not obvious whether it's workable or not. One of the challenges with battery swapping, and there's some Australian companies as well, I think. One of the challenges with battery swapping is that the most expensive part of the vehicle is the battery, and now you have to double at least. You're going to have something like twice as many batteries in the system. Not exactly clear exactly how many batteries you need in a battery swapping system, but you need something like double. So that's the most expensive component. The other thing is the batteries have always got to be where you need them. So you're going to have some sort of system for shifting batteries around the country, and they're big bits of kit. I think it's plausible. It obviously needs standards between truck makers and battery suppliers and all that kind of stuff. As I say, the Chinese are doing it, so it's possible. It's not completely obvious that that's going to be the best way forward.
Okay, it's an interesting point about the battery being the most expensive part, because that obviously doesn't help. Okay, cool. So here we've got an article about that swap and go system between Sydney and Brisbane using exchangeable batteries. And I've seen it as well for like scooters and bikes and things like that. I can maybe imagine it being more of a thing in like developing countries where they have a lot more of that small kind of transport, and maybe it's not so easy to charge at home. But yeah, it should be interesting. I got a good question. Let me find it now. Oh yeah. So when you mentioned that, trucks, they, might drive 300 Ks on average, but then they go back again. And I got a comment from Peter Ross. Yes, but you don't unload it in 3 minutes. So charge time exists as it does for driver rest periods. And that's the best argument that I've heard in favor of, usually the argument is it a battery or is it hydrogen? The biggest argument that I found in favor of battery electric was, well, in Europe, you can only drive for like 5 hours or something like that. And then you have to have a rest period and you can just recharge in that time.
Yeah.
What do you think about that?
Well, I think that's right. I think Peter's absolutely right about that. So the typical turnaround time in our warehouse here is about 20 minutes. In 20 minutes, you have got time to charge, get half a battery fill if you're quick with a high powered charger. You do have driver rest periods every 4.5 hours, and that's absolutely right, 45 minutes. And they can be used also. What we've found actually recently is that it's better not to wait to the full 45 minutes, but for the full 4.5 hours. If you go for about 2.5 hours and you partially charge for half an hour, you just add a little bit to your journey, then that makes quite a big difference to the size of battery that you need. So with battery, it's all about total distance total time that you travel. You're depleting your battery for length of time. If you want to go for 4.5 hours, you have to have 4.5 hours of battery. If you want to go 2.5 hours, you only have to have 2.5 hours of battery, and that's a much smaller battery, right? So you can, by combining charging at depots and charging at rest stops, you can bring batteries down to much more manageable levels. They're still big. Okay. They're still big, but they're much more manageable.
Okay, let's move on to hydrogen now, because I'm just conscious that time's ticking along. And sure, anyone that follows you on LinkedIn would be aware that you're a huge hydrogen enthusiast. Tell me why hydrogen is so great, or what use cases do you see? And that's a little bit of Australian sarcasm. Yeah, just in case there's anybody who maybe English is their second language and you didn't catch that. Yeah, tell me what you think about hydrogen and where, if anywhere, you see it fitting in, and then I'm going to try hard to play the role of hydrogen advocate and get a nice grounded, complete argument. And sure. Anybody watching that is a fan of hydrogen, because that was the most popular poll result was hydrogen. So obviously a lot of people think that this is going to be it. So if you were somebody that would vote number one hydrogen for trucks, then tell us in the comments why you think that. And yeah, then we can put David to spaces.
I don't think hydrogen will fly for trucks. There's two reasons. The truck costs too much money, and the energy costs too much money. And they're the reasons. So why does a truck cost too much money? Well, the truck is a battery electric truck. It's a battery electric platform. So it's
a hydrogen truck.
A hydrogen truck. Yeah. A hydrogen truck is a battery electric truck. It has a electric drive. It has an inverter and a significant battery. The Daimler truck has a 70 kilowatt hour battery, which is not huge, but it's still significant. And then on top of that battery electric vehicle, it has a whole bunch of rather expensive hydrogen stuff. Fuel cell, which is expensive technology, full of platinum, which is getting increasingly rare. It's got hydrogen tanks, hydrogen delivery capabilities. So that's an expensive bit of kit, much more expensive than a battery electric vehicle, and certainly much more expensive than the kind of vehicles with pantograph electric vehicles, which we'll talk about later. Second problem is the energy costs, and this is really the Achilles heel of hydrogen is its low efficiency, and the problem is that you take your nice renewable electricity, and you have to electrolyze water with it. You then create hydrogen, you compress it and pump it and transport it and put it through a fuel cell. The fuel cell has to converts heat into work. As engineers will know, it has to satisfy the second law of thermodynamics. It's 50% efficient. When you go through all of that stuff, you end up with about 20 or 25% of the energy you started with at the wheels of the vehicle. So you've thrown away 75 or 80% of the energy that you started with. That energy has to be paid for. It doesn't come for free. And what that means is that the energy cost of running a hydrogen fuel cell truck is about 3 and a bit times the cost of running an electric truck. The energy cost is a big part of current diesel vehicles. It's about 40% of the cost of running the vehicle. So you are substantially increasing your energy costs and substantially increasing your capital costs, which is why when truck fleets are offered the choice, do you want vehicle A, which it costs you X, and vehicle B, which costs you 2X, and you want vehicle A, which costs Y to run, and vehicle B, which costs 3Y to run, the calculation fleets are not going to buy these vehicles. They're just too expensive to run.
Yeah. Okay. So we have a couple of comments that are kind of, having the arguments in the comment section. So Peter Ross, isn't hydrogen just a terribly inefficient battery using massive amounts of energy to create something that's hard to transport and not much more energy efficient than diesel? And
I couldn't have said it better myself. It's perfect. Thank you, Peter.
And then in the other corner, whoops, no, this is the wrong comment. In response to that, yes, but that's okay when you have plenty of cheaper energy you can't transport over vast distance any other way. I mean, obviously, everybody isn't swayed by this. Hydrogen trucks are more expensive, and we won't have, they're less efficient. Because I was just showing this article from Volvo and Daimler teaming up on a hydrogen fuel cell joint venture. And then in the NREL report, their executive summary has battery electric vehicles cost competitive for smaller trucks before 2030. So, that's the use case I think you were mostly talking about before. For short haul, less than 500 mile, which is like, I think, 800 kilometers before 2035. And hydrogen fuel cell electric vehicles tend to become cost competitive for long haul, greater than 500 miles by 2035. So, according to that, we're still 13 years away from hydrogen trucks being, cheaper than anything. But they do see this long range trucks being the solution for that. They don't say, at some point that battery electric trucks are going to be cheaper than fuel cell for these like really long distance journeys. Do you agree that for these like specific use cases it's going to be hydrogen, or do you just see no place for it at all?
Well, the big question really is whether you spin up this hydrogen economy for these small use cases. Right, the hydrogen economy is an incredibly expensive thing to spin up. You've got to manufacture it and you've got to ship it. Here, let me give you one little number. Right, if you want to ship the same amount of energy as a diesel tanker, you need 18 hydrogen tankers. Hydrogen is really hard to move around. You need 18 44-ton trucks to move the same amount of hydrogen as you need to move the same amount of energy as diesel. So it's difficult to move. It's wasteful to move. And it is expensive to make. So it's not at all obvious to me that you move hydrogen to these remote places where you're going to need to fuel vehicles. I think much more likely for, if you want to drive across the Nullarbor Plain, across thousands of kilometers of Australia, across the US, I think it's much more likely that we'll have hybrid electric vehicles, which will probably use diesel or they'll use biofuel. These are a small proportion of trucks on the whole. And what we should focus on here is decarbonising the vast majority of trucks that do smaller journeys, that do shorter journeys, and that do journeys in more populated areas where there's infrastructure. That's the vast majority of trucks. We should focus on those. We shouldn't say, how are we going to decarbonise the Stuart Highway, from Adelaide to Darwin. That's not the start of this problem. The start is the zillions of trucks running in up and down the east coast of Australia, or in populated areas of Europe or the US. Let's start with all of those things, which are much easier to do. And the small proportion of vehicles in the remote areas, in Australia, is about maybe 10%, less than that. Vehicles which are running in these remote areas. Let's not get wrapped around the ankle trying to work out what the solution is for decarbonising them when we've got the whole big problem of everything else to do first. I think those vehicles can run on hybrid vehicles with biofuel range extenders or diesel range extenders, and you'll have a few diesel emissions.
Okay. I just wanted to point out some of the places that you're saying. So across the Nullarbor is, if you're going from Adelaide to Perth, then you go along this highway with practically nothing, no towns of any size. Then noticing Google does not put Darwin on their map of Australia when you're zoomed out at this level, which is pretty rough. I mean, they've even got the ACT on there. I don't know, Tasmania might be missing Hobart, but I've covered it up with all the places that I either want to go or have been. I did actually hear a project of some like rest stop owner somewhere along the Nullarbor, and he's got a oh, that looks pretty. He's got a fish and chips, or maybe not fish, but he's selling hot chips, and he's using the chip oil to power like a diesel generator to charge batteries to allow you to recharge if you're driving. You can drive your electric car across the Nullarbor if you want, but I think if you tried to recharge a semi-trailer, then you might be there for a while, and you'd have to get through a lot of orders of chips before you could get enough energy to do it.
You could just use that oil straight in the diesel, of course.
Yeah. Well, that wasn't the project, but yeah. So yeah, there's options. Okay. All right. So I mean, I make lots of videos about hydrogen, and I will again in the future. And I think all of the issues we could get into more now in more depth. It's more just things that are common to the whole hydrogen economy. So I think we'll leave it there, and we'll move on to the next technology. Oh wait, first there was a question that I wanted to cover. Someone was asking why not solar powered trucks, and so I just needed to very quickly show that yes, there you go. The Germans have an electric truck. I don't know what the word for okay, here we go. We have it. I should have mentioned as well, I have Kevin here again, helping behind the scenes, not showing his face, but sometimes when things pop up randomly, that's because Kevin has anticipated our needs and shared it. So so the comment was again from Pinata Oblongata, and if Aptera and Cyan can put PV panels in passenger cars, why not panels on trucks? So that is a thing that's starting, and obviously it depends how much surface area you've got and how long you're sitting around in the sun. I do think that we'll start to see some transport assisted by solar power, but I don't know. What do you think, David? Are we ever going to see this be like a purely solar powered car, or will it always be just like a little range extender on sunny days?
Good for running the fridge. That's a refrigerated vehicle probably. Good for running the fridge. Charge up a little battery. You do have refrigerated vehicles that get stuck in on the motorway outside of Dover, which we've got a bit of a problem at the moment with Brexit and all that stuff. They get stuck. They've got to run their fridges, right? And so you've got here's a way of generating some power for your fridge. You can never run the whole truck on that. I mean, a truck needs 150 or 200 kilowatts to just run on the straight road. If you've tried to put solar panels on your house, that amount of solar panels on the top of that truck is about 6 kilowatts or something like that. So you're out by a huge factor on the area of solar panels needed. So that's never going to work. But it's not bad for running the fridge, that kind of thing, running auxiliary loads.
Okay. So let's see how that goes, but I don't think it's going to prevent us from needing these other solutions. So now I want to move on to electric roads, and the different forms that can take. And I know that this is a topic you've researched a lot, David. So can you tell us what's the options for an electric road?
So the point about the electric road is to take the electrons to the vehicle in a wire rather than in a box, rather than the battery. So it's the same sort of technology as we use for electric trains, overhead. Well, it can be. There are different kinds of technical solutions. That is my preferred solution, and it's the most technologically ready, if you like, highest readiness. There's systems running in Germany at the moment. They've run in Sweden and US, and they are surprisingly effective. It's quite remarkable, actually. People hear about these kind of trucks with overhead. You have a pantograph mechanism, reaches up from the truck, reaches up to the wires. There you go. That's the kind of thing. It's a deployable pantograph, so the pantograph goes up and down. That means that if you want to pass the truck in front, you just drop the pantograph, you go around the next truck, and then you put it back up again on the wire. And the vehicles will typically carry enough power to go some distance. Now, vehicles that are just traveling up and down the motorway, you typically just put the cables over heavily populated, heavily trafficked roads, motorways and freeways. And so vehicles that go up and down between warehouses, distribution centers, only need a small battery to get off the end of the, get off at the exit and drive to their, 10 kilometers or something to distribution center, load, unload, unload and load, and go back and drive back up and down the motorway with this technology. People look at this and they say you're completely mad. When you stand next to it and you see it working, you think, oh, that's obvious. Of course that works. It just does. It's one of these things. It simply just works. And what it means is that you can have much, much smaller batteries. So you can have a 150 kilowatt hour battery in almost every truck in the UK. Not all. There are trucks that go do journeys around remote areas of the country which need more battery than that, and will need some static charges. But in general, it reduces battery sizes by at least a factor of 2, if not more than that. So you go from these crazy batteries, megawatt hour batteries, down to, well, everything in the UK can be done with a 500 kilowatt hour battery or less, which is pretty good. And a very large proportion of the journeys can be done with 150 kilowatt hours or less. So you're going to much, much smaller batteries. These are much more efficient even than straight battery electric vehicle, because when they're running on the highway, the electricity comes straight from the wire, goes through the inverter and straight to the electric motor. It doesn't have to go in and out of the battery, which has got a round trip efficiency of 85 or 90%. So you don't lose any energy. It's the most efficient way you can run an electric vehicle. And so it uses the least amount of energy. It's the cheapest way to run. And you can have whatever range you need as long as you've got the wires.
Okay, and why this like overhead tram style system rather than this? This is an article from Volvo. So there they've got it laid underneath. Yeah. That looks a lot nicer, doesn't it? It's very neat.
Yeah, neat and tidy. Yes.
Does this work like your wireless phone charger works? Is it kind of the same principle, but you're just driving along a giant wireless phone charger?
No, this one's more like a Scalextric car. I don't know if you had one of those when you were a kid, but with a little conductive
rails,
track.
Yeah.
Conductive track. So there are various technologies. There's conductive. There's 3 different conductive technology. This is one, which is conductors in the road. There's the one we've talked about, conductors overhead, and there's another third one which actually is becoming widely used in mines. And I know that BHP is looking at for iron ore mines in Australia, and that is a track which is actually at the side of the truck, and the truck has an arm, which a big haul truck, 200-ton haul truck, big arm at the side, which plugs into a conductive rail. Now you can do that third one in a restricted mine site where there's nobody around. You have much less safety issues, and they're low speeds. And it has an ability to give much higher powers. And a very attractive thing about it is that you can move the charging system around. You move that infrastructure around. When your haul road moves to a slightly different place, you can redeploy that system. So we'll see that in mining trucks, conductive. They've done the calculations. They've worked out that hydrogen just doesn't make any sense at all for mining trucks. And we'll see those conductive systems with conductors at the side in that application. It doesn't
Some
work on
companies
highways.
are using hydrogen for mining. I think Fortescue again, because
Right, Rosie?
Twiggy Forrest, he really likes
Yeah,
hydrogen.
yeah. But if you do the calculations, it just doesn't work. You need 3.5 times more energy to run a hydrogen-powered truck than to run one of
Yeah.
these trucks. So if he's generating his own electricity on the site, instead of needing, 100 megawatts of wind turbines and solar power to drive his mining trucks, he needs 330 megawatts. He's got to build this
Yeah, but
much, much
that's
bigger plant, right?
so much more exciting project to announce is a
Exactly
300
right.
megawatt wind farm or solar
Exactly
farm.
right. Exactly right.
Yeah. Okay. Let's keep pushing on because I know you said, people think, oh, this is crazy when they hear about it, and I
Yeah.
definitely was in that category. So I think I can give you some of the obvious objections to this because these are the thoughts that I had. So first of all, the scale of roads that you would need to add these power lines, overhead power lines to, and the ability of somebody to pay for all that upfront. I mean, what's the feasibility of this? How much is it going to cost? Do you need like really busy roads for it to ever pay for itself? Can private industry plausibly do this on their own, or does it need to be a big government, infrastructure project? How can this possibly work out?
Well, that's a good question. First of all, it can pay for itself. You need reasonably busy roads because you need a certain number of trucks per day to buy electricity, and because it's the sales of electricity which is going to pay for the infrastructure in the end. The challenge, and in the UK, we've concluded that we need about 5,000 kilometres, 5 or 7,000 kilometres of this stuff, and that will cost of order 20 billion pounds, which seems like a lot of money, except that the government's budget for roads for 2020 to 2025 is 28 billion, right? So that's 50% more for the whole budget, just budget for the roads. The high speed train that we're building here in the UK, which is going to transfer a few passengers from London up north, that's going to cost 106 billion pounds. So for a fifth of the cost of one high speed train, we can electrify most of the motorway, the necessary motorway network. So when you put the costs into perspective, they're not quite that bad. The challenge with this is the chicken and egg challenge that you have with any big infrastructure project. When they built the London Underground in 1870, 1860, nobody said, well, look, we're only going to have 100 passengers on this, and so the tickets will be so expensive we can't possibly afford to build an underground railway line.
Yeah, it was the same argument that the Australian government used for why we don't need decent broadband internet in Australia, because nobody even uses it.
Use
so
it. That's right.
why would we roll it out? You just want to watch porn.
That's
That
right.
was the most favorite argument thrown around. And then the pandemic happened, and all of a sudden it turned out there's all sorts of things that you could do
You
if
can
you
do
had
it. That's right.
decent internet. So yeah, thanks
Exactly right.
Australian government.
So infrastructure projects generally take government to get involved. The reason that government is involved in this case is because during the early phases of this, you don't have many trucks on the road that are buying electricity. And so it's very difficult to make it pay at the start. You need to get the system in place and a reasonable uptake before it can pay for itself. And that's why you need some sort of government involvement or government guarantees of income so that you can take this step into a project which isn't going to pay for itself in the first 5 years. You can, in the way that you build it out, you can take account of that. You can do it in phases that make it cheaper to start with and improve the business model at the early phases. For example, you can make it lower power. One of the big costs is providing little substations along the road which put the power into the lines. Now you can reduce the power of the system early on because you've got fewer vehicles traveling on it, and that reduces the costs. And then you can increase the power later and get and that's what we're recommending in that report we've just written on this for the UK. That's the way to go.
Okay. And I'll put a link to that report and all the other resources that we used today in the description afterwards, if you want to check them out.
That one's going to be published next week, so it's slightly difficult to link to it.
Okay. Well, you'll send me the link and I'll add it as a comment.
Absolutely
after.
will. Absolutely
Everyone will check back in a week's time for that hot off the press breaking news. Yeah. Okay. So, I mean, obviously, I do trust your analysis. I know you've thought very deeply about this, and I can get behind your opinion that this, or more than an opinion, your findings that this is the best way to do what you can with this catenary charging. But will we? Do you think governments will put this in place? Can you? I don't know. Maybe I'm too cynical, but I just can't see us all, agreeing to do something so sensible when the whole energy transition has been really scrappy. Like small initiatives. Some governments have done some small things. Some governments have done bigger things, but in general, it's been reliant. I mean, I really think that it is the capitalist marketplace that has driven the bulk of emissions reductions to date, together with really great technology improvements, so that renewable electricity and now electric cars are just competitive technologies. Do you see that we can do something smarter this time around, given that we've got to go faster than we have been?
Well, that's a good question. I mean, there's a whole really difficult problem with the energy transition, that everything is changing at once, and all these interacting systems are changing at once. The energy system, the transport system, the logistics system, the infrastructure. All these things are changing at once, and you've got to try to navigate that, and it's very, very difficult. What can I say? There are a couple of things in favour. First of all, there is quite a lot of interest around this technology in many European countries at the moment, and in India and in China. I'm involved in projects in China and India to some extent on these technologies. So it's not just a fantasy in the UK. It's actually something which is picking up quite a lot of interest around the world.
There's a few that physically exist, right? Like there's this German one. I think there's an Italian and is it Swedish? I can't remember. There's a few around that. Yeah.
There was a Swedish test site. The main ones which are running at the moment are in Germany, but they're running in real logistics operations, and they've been running for several years, and they're expanding the activity, and they're running very well, without any problems. So the signs are good from that point of view. The other thing is, the UK government is in the process of working towards some trials of different technologies, and they're planning to have a trial of electric roads and of hydrogen-powered trucks and of big battery vehicles, we believe, over the next few years. So what they're trying to do is to generate the information necessary to make a decision, and they want to make a decision in the latter half of this decade, 26, 27, to decide which way the UK should go from this point of view, infrastructure point of view. There's no doubt that if the government has to pay for it, if they're looking at whole life costs of the whole system, if the government has to pay, it's much cheaper for them to pay to put in the infrastructure than to pay hydrogen subsidies forever. So if you just do the simple economics from the point of view of the government, it's way better to assist the private industry to build that infrastructure than it is to pay hydrogen subsidies, and it's way better for the truck operators. They'll buy much cheaper, much more productive trucks. So the indicators are in the right direction. Whether humans can make this decision, whether governments can make this decision or not, is a good question. I think that is the ultimate question, Rosie. I think you've hit the nail on the head. It's not a technical question. It's not an economic question. It's an ideological question, probably.
Yeah, and it's not unique to trucks. It's you see it everywhere throughout the energy transition. So we don't need to answer it today. I'm sure we'll find out as years go on. We're pretty much out of time, but I just wanted to finish up with one question. It's also similar to a question I got from one of the Patreon team. So the question I got from Patreon was actually about which of these techs are the lightest, because obviously that affects efficiency as well. And then we've got this one comment from QA Library. Had a meeting with Nikola, Motors, Bosch, DAF, Packer, and found out a lot about hydrogen fuel cells. One main thing was hydrogen fuel cells were heavier and they're having issues with weight laws. And yeah, so is that the order that the weights go? I guess that catenary charging would be the lightest because you've got a small battery, followed by battery electric, followed by what's heavier out of hydrogen and just a normal diesel or biodiesel or whatever.
Well, diesel's pretty light. I mean, the weight, the winner in weight will be hydrogen fuel cell or big battery. Big batteries can get big and heavy. They can weigh many tons. So they will probably, the really big battery solutions are the heaviest, and that's they get the least viable. So on cost and on weight, hydrogen and batteries are big batteries are biggest on weight. Hydrogen batteries biggest on cost. Catenaries are best, by far the best on weight, lightweight, low cost, but they have the infrastructure. And the reason, of course, is that you get a lot more stuff at the side of the road. That's where the weight's gone, and to deliver the power to the trucks.
So okay, we're out of time now. I need to go. I actually have tickets to a Midnight Oil concert this evening, so that's why I'm trying to really push the time. I don't imagine I'll get another chance, so I can't be late. So yeah, I will cut you off. Sorry. Sorry, David. No, I know you've got more to say, but you can come back on another time, and we'll find something else to talk about. I think this has been a really good topic, and I want to thank you a lot because I've learned a lot, thought about it more deeply than I had before. So just pushing on, I want to thank again WeatherGuard Lightning Tech for sponsoring the live stream. They also have a great tech newsletter and podcast, the Uptime Wind Energy podcast, which I co-host with Alan Hall each week. The links are in the description. We talk about clean energy tech news, and in the latest episode, we talk about another cyber attack on wind turbine manufacturer, Nordex. We also talk about renewable energy misinformation on Facebook and whether we can or should do anything about it, and about an interesting wind farm noise lawsuit that's just been through the Australian courts. So check that out on your favorite podcast app, or you can watch it here on YouTube. Again, the link's in the description. And I also need to thank again the Engineering with Rosie Patreon team for their support. It means so much to me. It's not just the financial support, which definitely helps me to get support for the channel to make it more professional, but just all of the ideas and help that I get putting these videos together is very, very valuable. So the link again is in the description if you want to join us. And then just thanks, David, for taking the time to chat with us today. It's been really good. I think that there've been lots of good audience questions, so I think everybody has enjoyed it. So thanks so much for spending the time with us.
No worries. Thanks, Rosie. Keep up the good work.
And thank you. And thanks so much for people who are here watching. We've got a good number today live, and that's even that we're at this terrible time for Americans. I saw some people joined at like 3 a.m. American time, so that's very much appreciated. Next live stream, actually, I'll probably be in America. I may do a live stream from, there's a clean power conference in Texas that I am planning to attend. So I might do a live stream from there and feature some of the interesting technologies talked about. And then other than that, next week, new video on carbon capture and utilization, which is something I have been working on for probably 6 months on this video, but I think it's going to be a good one. So check that out next week. Thanks again, David. Thanks again, everyone, for watching, and I'll see you next time.
See you.